The first step in any problem is to decide what information you're being given and what information you're being asked for. That way you know when you solve the problem and what information you're going to use to get there. So let's do that. First, what are we being asked for? This problem is pretty simple. We want to know which of the following species has 28 electrons. Okay? And so what we're given then is some information about these following species that's going to tell us how many electrons they have. In this case, the easiest way I think to approach it is just to look at the element, determine how many protons there are, and then use the charge on the species in order to determine how many electrons there must be. So let's start with the first one, zinc. If we look at the periodic table, we're going to find that zinc is element number 30. What that means is that zinc contains 30 protons. However, this particular atom has a 2+ charge. What that means is that we're going to have 2 less electrons than protons. That's what the 2+ charge means. So let's call that missing. Two electrons. And if we're missing 2 electrons, our total number of electrons must be 28 electrons. So that's at least a correct answer to this problem. Next we can look at nickel. Nickel is element number 28, which means that it has 28 protons. It's not missing any electrons because it's a neutral molecule. There's no charge given here in the upper right. And so that must mean that it also has 28 electrons. And so here we have that answer 1 and answer 2 are correct. Let's look at the last one. Copper. Copper is element 29. That means that there's 29 protons. It also has a +1 charge, which means that it is missing 1 electron. This also then gives us 28 electrons for copper. And so in this case we find that all 3 of these species have the same number of electrons. A situation that we'll find later means that they're isoelectronic. But for now, what that means is that the answer is E, all of the above. Now, let's move on to the next problem. Again, we can start this problem by deciding what we're being asked for and what information we're being given. So, let's figure this out. What we're being asked for is again fairly easy to decide. What is the atomic weight of another isotope of bromine given the natural abundance of one of the isotopes of bromine? Alright, so we're given some information about bromine. We're also given that there's only one other isotope. And so we have a situation where we have 2 isotopes, we're given information about one, and then we're asked to find information about the other. In this case, it's information about the atomic mass. When we're thinking about atomic mass, then this is a reference to the average atomic mass that we would find on the periodic table. And the average atomic mass is just the sum of the contributions from the different isotopes. We can express this mathematically in a simple formula. The idea is that we're going to have the fraction expressed by x of a particular isotope. In this case, we start with bromine 79. So let's write that down. 79 bromine. So the fraction due to isotope 79 of bromine, and then the mass multiplied by the mass of that. Then we add in the next contribution, which is just the contribution due to the fraction of our unknown bromine isotope. So let's put a question mark, because we don't know what it is, but we're going to find out, times the mass of that particular isotope. Okay, and then what happens is if we take those two fractions, multiply them each by their masses, and then add them together, what we're going to end up with is the average atomic mass. Good. So now all we need to do is fill in the numbers here, some of which are given to us, and some of which we're going to find. So let's start at the left. We're given some information about the fraction of bromine 79, right? We know up here that it's 54.8%. That's the same thing as having a fraction of 0.548. We just divide by 100 in order to convert a percentage into a fraction. Then we also have to know something about the mass. But this is relatively simple, because when we look at bromine 79, what that means, what the 79 means, is that there are 79 protons plus neutrons. We also know that the atomic mass for a proton and neutron are both 1, and so the total atomic mass for that isotope must also be 79 atomic mass units. Then we need to add in the fraction of the other bromine. How do we do that? Well, something to realize is that the total amount of bromine is just going to be equal to 1. The fraction 1 is the total amount. It's like 100%. And that's going to be equal to the fraction of bromine 79 plus the fraction of bromine that we don't know. What this means then is that we can rearrange this equation and we find that the fraction of bromine that we don't know is just equal to 1 minus the fraction of bromine 79. And we know the fraction of bromine 79, we've already used that. So let's go ahead and make that substitution. 1 minus the fraction, which again is 0.548. Then we multiply this by the mass of that unknown bromine. That's what we're trying to find, so let's keep that written out that way. The mass of our unknown bromine. And that's going to give us the average molecular mass, or the average atomic mass in this case, which is given to us from the periodic table as 79.90 atomic mass units. Great. Now we have this problem basically solved. All we need to do is run some numbers, rearrange it, and then read off our answer. So let's go ahead and do that. On the left-hand side of the equation, we're going to find that 0.548 times 79 is just equal to 43.92 atomic mass units. At the same time, we can work out 1 minus 0.548. That's just going to be equal to 0.452. We still keep this mass of our unknown bromine. And that's still equal to 79.90 AMU. I know right now I'm moving a little slow solving this problem, but it's early in the semester and I want to make sure that I'm making all these steps abundantly clear. So let's just rearrange this now. What we're going to find is that the mass of our unknown bromine is going to be equal to 79.90 atomic mass units minus what we have on the left-hand side here, 43.29, 43.29 atomic mass units. Then we're going to divide this all by what we were multiplying the unknown bromine mass by, which is 0.452. Alright, and so we just need to run these numbers. One thing I want to highlight here for us before we go on is that we're subtracting two numbers that have the same units, atomic mass units. That's good. And on the bottom, there's no unit associated with that number. So our final answer is going to have a volume that's in terms of atomic mass units, which is exactly what we wanted to have. So let's go ahead and do that. What we're going to find is that the mass of our unknown bromine isotope is just going to be equal to 81 atomic mass units. And then we can go back and look for this in our answers, which in this case is answer D. And that's the answer we have for this problem.